Hey guys, Jay Bish here for another online chemistry lesson. Hope the last lesson worked out really well for you and you were able to make use of those notes and the follow-up questions and those discussion forums that we had open. In this video, we're going to be covering addition and elimination reactions and reaction pathways. But first, a word from our sponsor. Yeah, no, we don't have any sponsors yet. Sony. Let's jump right into it. Addition and elimination reactions. Here are some of the key ideas. If you look up here, here are some of the key ideas that we're going to be going through this lesson. Feel free to pause it and write them down as you see. And we are off. Addition reactions. Addition reactions, by definition, occur when atoms add a substituent across a carbon-carbon multiple bond. Those most simplest are referred to as hydrogenation. So hydrogenation is our first type of addition reaction that we're going to be talking about today. Here we have an unsaturated hydrocarbon of ethene. We are adding the H2 along with the platinum catalyst. As a result, we're finishing with a fully saturated carbon of ethane, a fully saturated hydrocarbon of ethane. The next type of addition reaction we're going to be talking about is halogenation. Very similar to hydrogenation, those halogenation ones, if we're looking down at this screen, the halogenation is the addition of a halogen, or those C2, those group 17 elements, across a multiple bond. As you can see here, the chlorine is being added to this ethene molecule and it's breaking apart that double bond and adding in those two individual chlorine molecules. The third type of addition reaction we're going to be talking about today is hydrohalogenation. Hydrohalogens are essentially those hydrogen and halogen molecules like hydrochloric acid. Russian chemist Vladimir Markovnikov studied this reaction and discovered a trend. 90% of the reactions resulted in hydrogen attaching to that end carbon and the halogen attaching to that central carbon. The other 10% will be the hydrogen attaching to that center carbon and the halogen attaching to that outer carbon. The fourth type of reaction we're going to be talking about today is hydration, or the addition of water into an unsaturated hydrocarbon. Very simply put, the water breaks apart that hydrogen molecule, creating an alcohol. This is done at incredibly high temperatures. We're talking like 300 degrees Celsius and extremely high pressures, like 60 atmospheres. The very last type of addition reaction we're going to be talking about today is called polymerization. Now, this is the creation of polymers or long chain hydrocarbon molecules. Essentially what happens is at very high temperatures and pressures, a solution of alkene will break that double bond in the center in here, causing all of these extra bonds, these floating bonds to start joining together. That's if you've got a pure solution. You need to have a pure solution of alkene or an ethene. Finishing off this video today, we're actually going to be talking about the opposite of addition reactions, and those are elimination reactions. Now, elimination reactions are the complete opposite of addition type reactions. Addition reactions was to remove that double bond that we had in the front here and we're adding in something. We're adding in either it be hydrogen or a halogen or something like that. Elimination is going to be removing something like these hydrogen molecules, like these extra hydrogen molecules. We're going to be removing those and creating that double bond again. Two definitions we're going to be needing for this section. Elimination is the removal of substituents in order to form double bonds, and reflux. So a reflux is the process of heating a vessel and catching that evaporated content, returning it back to that vessel again to continue the reaction. Elimination reactions usually involve heating a haloalkane in reflux with a concentrated solution of sodium hydroxide. Now that equation is in those notes and I'm going to have it drawn up on the screen right now. The reaction produces the alkene, sodium bromide, and water. And that's it, guys. That's it for chapter 10.1 this week. More in the next video, more specifically on oxidation and reduction reactions. Feel free to give those end of chapter questions a quick go. Answers are up on Canvas along with the PDF of all of these notes with more details and all those equations that you can copy down into your own notes. Let me know if you have any feedback, and until next time, thanks for listening. Keep safe, keep healthy. Peace.